Hi, 8th graders. This week during our Algebra 1 class, we are going to learn about the rate of change and slope, as well as the slope-intercept form. These are lessons 4.2 and 4.3 in your textbook. Our objectives for these lessons are to calculate and interpret slope by using the slope formula, to rewrite equations in slope-intercept form, as well as to graph and interpret linear functions. Our I can statements are: I can find and interpret the rate of change and slopes of lines, and I can graph equations in slope-intercept form. The following are vocabulary words that we need to own in order to have an easy time solving exercises. First of all, the rate of change. This describes how one quantity changes in relation to another quantity. We can apply this formula to determine the rate of change. So the changes in the y values are divided by the changes in the x values. The rate of change describes the relationship of quantity changes in x and y. For the example in this slide, y represents the number of pancakes, while x represents the cups of flour. So what we're doing here is finding the rate of change of the function by using these 2 points from the table. We apply the formula, changes in y divided by changes in x. As seen in the table, y represents pancakes, so we have the change in pancakes as a numerator, and then x represents the amount of flours measured in cups. So down here in the denominator, change in flour. We take a look at the amounts. So we've got 24 and 12. We are going to write these as the denominators or as a change in y. So 24 minus 12 over 4 minus 2. We solve this. 24 minus 12 is 12 over 4 minus 2, which is 2. We can simplify or divide here. So 12 divided by 2 equals 6, or if we simplify, it's 6 over 1, which is translated into 6. Therefore, we say that the rate is 6, which means that we can get 6 pancakes from each cup of flour. The slope of a line is the numerical measure of its inclination. The slope of a non-vertical line through any 2 points, x and y, can be found by applying the slope formula right here. So the slope is represented by the variable m, and to find the slope we apply the formula y2 minus y1, or the ordered pairs, right? And over x2 minus xy. The y coordinates represent the rise of the function, while the x coordinates represent run. This means rise is the up and down movement, while run is the right to left movement. If we look at this example, we are given 2 ordered pairs, and we are going to apply these 2 ordered pairs to the slope formula. So slope is represented by m. Our first ordered pair is -3 and 4. So -3 is x1 and 4 is y1. and 1 and 7, in which the first number 1 represents x, so this is x2, and 7 is y2. So we are going to replace these numbers in the formula, and we have 7 minus 4 over 1 minus negative 3. We solve these and we have that 7 minus 4 is 3 over 1 minus negative 3, which is 4. And this is going to help us plot our point here in the graph or in the coordinate system. Next, we have graphing linear functions in slope-intercept form. In slope-intercept form, as I mentioned before, M represents the slope and B represents the y-intercept. I guess you remember we have worked with these before. Okay, M is the slope, B the y-intercept. The variables M and B are called parameters because changing their value changes the graph of a function. When graphing a line in slope-intercept form, B is what we are going to graph first, and this is because we need a starting point. So B, or the y-intercept, is going to be our starting point. In this example, where we are given the slope being negative 3 over 2 and a y-intercept of 4, the first point we will plot is 4, positive 4 right here. The slope is negative 3 over 2, so we count 3 units down and 2 units right to graph this function. So we start counting, right? 3 units down, 1, 2, 3, and 2 units right, 1, 2. This is what we call the rise and the run. Once again, 3 units down because it's negative, 1, 2, 3, 2 units right, 1, 2. We plot a third point, then we are going to use a vertical line to connect these points and graph our function. The graphs of a constant function have a slope 0, which means there is no x-intercept, okay? Because the slope is 0, the graph will not rise, but can run left to right any amount, resulting in a horizontal graph as the example on this slide. So in order to plot these, we are given the value for y, which is 2, so we can immediately plot these in our graph. And then the slope is 0, so we are going to graph this function as a horizontal line going through the y-intercept when the slope is 0.